I'll be talking with you today about juvenile graphical perception. In short, we conducted a study to investigate the differences in graphical perception between children and adults. Our study population was children aged 8 to 12 from a Boston after-school program and adult graduate computer science students at Northeastern University. I'll refer to them as children and adults going forward. Now, at this point, you may already be thinking to yourself, another graphical perception study, forget it. Or, I already know the difference, children will be less accurate. That's fair, but give me a listen. First, think back to those rosy days in elementary and middle school. Chances are you used visualization then more than you do now. Educators and developmental psychologists have determined that around 50% of math textbook pages involve a visualization. Now tell me, how many papers have you read that make sure our research applies to them? I'd have to guess not many. This is the gap we want to fill. Since graphical perception is the foundation of many of the visualization community's design principles, we need to know if the results from the adults are the same as the children's. Many, including myself, initially would jump to the conclusion that children are worse. While this is fair, what we are not sure of is what kind of patterns of errors they will have, and by how much worse they will be. You see, children aren't just using the same cognitive strategies in a less practiced way. They actually think about many mathematical problems using entirely different strategies. For instance, developmental psychologists have found that children reach adult levels of perceptual acuity and area discrimination earlier than they do for length discrimination. Since we weren't certain how children would process the visualizations, we left our hypothesis relatively open. The three hypotheses we posed were 1. Children will have varying perceptual accuracy with different visual encodings. We kept this hypothesis deliberately broad and conducted a visual analysis later on to determine the rankings from most to least accurate. 2. Children's overall perceptual task accuracy will be lower than adults. Though we believe that children will likely be less accurate than adults due to lack of practice, what was interesting to see was if they were going to be equally less accurate across all the encodings, or did they develop their accuracy for certain encodings earlier than others? Finally, we took a page out of the developmental psychology book and looked if children and adults had regular patterns of over and underestimation. For instance, when the proportion is small, let's say 10%, did the participants regularly guess higher? And when the proportion was 90%, did participants regularly underestimate the true value? Looking for these patterns of bias can help us uncover the cognitive processes involved in graphical perception tasks. Now we can quickly cover the basics of the study before we jump into the results and discussion. As I said at the beginning, the two populations were children aged 8 to 12 from a Boston after-school program and graduate computer science students at Northeastern University. Both populations completed the exact same study online. We tested 5 visual encodings and tried to make them as simple as possible so as to only test the element in question. The adults completed the study remotely and asynchronously, while the children completed the study one-on-one with their usual teacher in the room. Before the study was run, the procedure and analysis were pre-registered on OSF. You can find a detailed description of the study at the link below, so I won't bore you with all the details. Instead, let's take a look at the results. Let's start by looking at the first hypothesis. We found that children's perception does vary due to the varied visual encodings. What may catch your eye is that position along an unaligned axis performs worse than length, which differs from the results presented by Cleveland and McGill and popularized in many design textbooks. Now, how do the children's results compare to the adults? They're similar. In fact, what surprised us is exactly how similar. The children followed the exact same pattern as the adults, but made errors that were about 2.5 percentage points larger on average. For instance, while adults were on average off from the true value by around 5 percentage points, the children would be off by about 7.5 percentage points. Finally, for our third hypothesis, we did not find any clear patterns of bias except for position along an unaligned axis, where both children and adults regularly underestimated the true value. Looking at these results, we can make a few design recommendations. First, from our results, we advise designers to follow the same graphical perception design recommendations. we use for adults. Second, we would like you to consider more than just the aggregate results. Here are the graphs for children and adults showing each individual's perceptual element rankings. Not going into too much detail, all those squiggles mean that there is a lot of variety and only a small percentage of individuals follow the same pattern as the aggregate. Knowing this, designers may want to spend less time focusing on perceptual accuracy and divert some of that focus on factors such as engagement or enjoyment. If perceptual accuracy is paramount, consider adding exact numbers or grid lines. Finally, we hope that future researchers present their findings in a manner that more closely reflects the results. We already demonstrated the importance of looking at the individual, but it would also be beneficial to show the rankings not as evenly spaced, but and separate them based off perceptual accuracy. Alright, let's recap everything real quick. We ran a classic graphical perception study comparing children and adults. We were interested in seeing the rankings of the visual encodings, how children compared to adults, and if there were any systematic biases. Our results indicate that children and adults are remarkably similar, but are slightly less accurate on graphical perception tests. Now, I want to leave you with a bit of a call to action. I hope today's presentation made it clear how important it is that we, as a community, work with children. When designing studies for them, it is helpful to understand their knowledge base at the age tested, conduct multiple pilot tests, and have an individual who studies or regularly works with children to assist you. One thing that should be noted and surprised us was how excited and enthusiastic the children were to complete a task that most adults would deem boring. With that in mind, we hope future researchers are not discouraged by the extra thought and care that needs to be taken in designing studies for children and continue to pursue this area of research. Thank you all for listening today. You can email me and find the paper and supplemental materials at the links below.